Hey there, Seahawks. It's Miss Adams, and in this video, we're going to learn about the central limit theorem. All right. So the central limit theorem is where we select a simple random sample of size n from any population with a mean mu and a standard deviation sigma. The central limit theorem, abbreviated CLT, says that when n is large, the sampling distribution of the sample mean is approximately normal. All right, so if I take a large sample, it's going to be approximately normal, even if it's coming from a population distribution that is not normal. The central limit theorem cannot be used with proportions, only with sampling distributions for means. So describing the shape of the sampling distribution of sample mean, the distribution will be approximately normal when either of the following is true. So the population distribution is approximately normal, or the sample size is large. In most cases, n has to be greater than or equal to 30. And that's the value we're going to go with. All right, so that's how we can determine if it's normal. If it comes from a population that's normal, or if my sample size is big enough to apply the central limit theorem. All right, an example, sampling from non-normal populations. Opening weekend earnings from top earning movies of all time are reported by the website Box Office Mojo. The histogram shows the distribution of earnings, rounded to the nearest million, of top 1,000 movies based on opening weekend's gross earnings. Note, there is one movie in each of these intervals. All right, so 225 to 250, 250 to 275, and 350 to 375. It's very little to see. Describe the shape of the sampling distribution of X bar for a simple random sample of size n equals 60 from the population of movies. Justify your answer. Well, if n equals 60, that is greater than or equal to 30, so the sampling distribution of X bar will be approximately normal by the central limit theorem. Describe the shape of the sampling distribution of X bar for a simple random sample of size 10 from the population of movies. So if my sample size was 10, that is less than 30, I wouldn't be able to apply the central limit theorem. So the sampling distribution of X bar will also be skewed to the right like the population distribution is, but not quite as strongly skewed as the population distribution. All right. Probabilities involving X bar. The opening weekend earnings of the top 1,000 movies of all time have the distribution that is strongly skewed right, with a mean of 43.8 million and a standard deviation of 33.2 million. Let X bar be the sample mean opening weekend earnings for a random sample of 50 movies from this population. Describe the shape, center, and variability of the sampling distribution of X bar of samples of size 50. So my shape is approximately normal. 50 is greater than or equal to 30, so central limit theorem. My center would be equal to my population mean of 43.8 million, and my variability, I have to take my standard deviation and divide by the square root of 50, my sample size. I get 4.7 million. What is the probability that a random sample of 50 of these movies will have average opening weekend earnings of less than 30 million? So I have a normal distribution with a mean of 43.8 million, a standard deviation of 4.7 million, and I need to go to 30 and below. Normal CDF, my lower bound would be negative 99999, upper bound 30, mean 43.8, and standard deviation 4.7. When I plug that into my calculator, I get 0.0017. So pretty small. All right, go Seahawks.